So one way of trying to get you to look at negative exponents, especially when the base of the expression is a number, is think about what does it look like when it's a positive situation, so therefore what does it look like when it's a negative situation. I'm talking about positive as the exponent's positive, the exponent's negative. So for the first one, 5 cubed is 125. It's asking you to write the answer as a positive exponent and then also the answer as a fraction. So if 5 cubed is 125, then 5 to the negative 3 is 1 over 125. It's not negative 125, it's 1 over 125. That negative 3 is really telling us that those 5s actually belong, in this case, in the denominator. So that would also be the other answer they're looking for, which is rewriting the exponent so that it's positive. So it'll be 1 over 5 cubed. If you haven't finished the rest of these, 2, 3, and 4, maybe this would be a good time to turn the video off and continue doing the problems on your own, and then turn the video back on when you're ready to continue. So 8 squared is 64, so 8 to the negative 2 is 1 over 64, or 1 over 8 squared. In problem 3, 3/4 squared would be 9/16, because you're actually squaring both the 3 and the 4. So 3 squared is 9, 4 squared is 16. When I turn that into a negative exponent, then that means that it's going to be 16 over 9. Because I am basically taking the reciprocal of the 3/4. In other words, the 4 goes into the numerator, the 3 goes into the denominator to make that exponent positive 2. It could also be written as 4 squared over 3 squared, which again supports that answer of 16 over 9. And the last one, for the 4th power, is 256. So for the negative 4th would be 1 over 256, or 1 over 4 to the 4th power. So keep in mind that if you're not sure about the negative exponent answer, think about what would the answer be if the exponent was positive, and then the negative case will be its reciprocal. So the reciprocal of 5 is 1/5, the reciprocal of 8 is 1/8, and the reciprocal of 3/4 is 4/3. For the next set of problems, you're being asked to come up with a number that is going to give me a final answer of 1. And the reason why I'm asking you to do this is because of what you're going to be doing in problems 9, 10, 11. So 2 times what number is going to be 1? 1/5 times what number is going to be 1, and so on. So if you haven't done this problem, go ahead and complete them, turn the video back on when you are ready to continue. So the number that I can double to get 1 is a half. So half of 2, or 2 times a half, is 1. 1/5 times 5 is also 1. 3/2 times 2/3 is 1, and 9 times 1/9 is 1. Now, how am I coming up with these numbers? Well, if you think about fractions for a moment, I'm trying to get a fraction equals 1, I want the numerator and denominator to be the same number. So if I start off with a 2, so basically what I want is the numerator and the denominator to both equal 2 when I'm finished. So the 2 itself is 2 over 1. And so if I want to get a 2 over 2, which equals 1, then that means the numerator of the second fraction has to be a 1, and the denominator of that second fraction will be 2, so that when I multiply across 2 times 1 and 1 times 2, I'm going to get 2/2, which is 1. Same thing like for problem 7, I start with 3/2, and I want a fraction that's going to equal 1 when I'm finished, which means the fraction is going to have a 3 in it and a 2 in it, because those are 2 numbers in my fraction. So if I would take what's called the reciprocal of the 3/2 and make it 2/3, I'm making sure that both the numerator and the denominator have the same two numbers, which is 3 and the 2. So that means I multiply across 3 times 2 and then 2 times 3, and the denominator I get 6, which is 1. So all these problems are basically representing a reciprocal. So the reciprocal of 1/5 is 5, or 5/1. And if I multiply 1/5 times 5/1, I get 5/5, or 1. Same thing for the last one, 9, or 9/1. If I multiply that by 1/9, I get 9/9, which equals 1. So why this skill is important to be able to write a value of 1 is that quite often inside of equations we are trying to make 1s or 0s. So for example, when we're solving an equation like 3x, I don't necessarily want to know what the value of 3x is. I want to know what 1x is. So that's why we divide both sides by 3. Here we're going to be doing problems 9, 10, 11. We're going to be changing the exponents of 3, 7, and 2/3 into an exponent of 1 and trying to figure out what base cubed is going to be 30. So just kind of a reminder, 3 cubed is 27, we've talked about that one before, and 4 cubed is 64. So the answer we're going to come up with a lot of these problems is not going to be that really nice integer answer. So it's going to be somewhere between 3 and 4. So I'd like you to think about number 9, what would I multiply to that 3 so I can change the exponent from a 3 to a 1? And like we do with all of our equation works, we're going to do the same thing to both sides of the equation. So once you think about what you would do here and how you might solve this problem, and then if you feel comfortable with it, put your work it out and put your the problem into the calculator and see what kind of answer you come up with. So problem number 9, I have an exponent of 3, and I want to get an exponent of 1. So what I'm going to do is I'm going to multiply the 3, or 3/1, by its reciprocal, which is 1/3. And that's going to give me 3/3, or 1. So I'm going to do an exponent of 1/3 to both sides. Now please understand, it's an exponent of 1/3. I'm not multiplying 30 by 1/3. I'm taking 30 to the exponent of 1/3. So these are exponents we're doing. So 3 times 1/3, that's going to be 3/3, or 1. And again, that's the exponent. I'm wanting the x to have is a 1. And then I'm putting in the calculator 30 to the 1/3 exponent. As I mentioned, 3 cubed is 27, and 4 cubed is 64. So this answer here should be somewhere between 3 and 4. So 30 raised to the exponent of 1/3. When you enter into 1/3, you may find you don't have a fraction key, so you generally put it in as a division problem. So for my calculators, for example, it would look something like this: 30 exponent, and then since the fraction is 1/3, I would suggest putting the 1/3 in parentheses. That way the calculator knows it's not 30 to the first power times 3, but 30 to the exponent of 1/3. Also, when entering it in, you're going to enter it in as a division problem, and your calculator may automatically turn that division sign into a fraction sign. So 30 to the 1/3 power, we get an answer that's approximately 3.107. If I put that in the calculator, 3.107 to the 3rd power, I should hopefully get an answer that's very, very close to 30. So 3.107 cubed is 29.993, which again is very close to 30. So that's the first one. Why don't you turn the video off and see if you can complete problem number 10. Turn the video back on when you are ready to continue. But again, you can always check your answer and take it to the 7th power, and you get something close to 14. All right, so in problem number 10, my exponent is 7, so basically 7 over 1 times something, and I want the answer to give me a fraction that's going to equal 1. So that's basically at 7 7. So I'm going to multiply again by its reciprocal. So x to the 7th is equal to 14. I chose this problem because quite often students see the 7 and 14, oh, the answer is 2. But actually 2 to the 7th power is much larger than 14. So I'm going to multiply both sides by an exponent of 1/7, and that gives me 7/7 as the exponent with the x, which is x to the first. So I'm doing x to the first equals 14 to the 1/7. Again, please understand that this is not 14 times 1/7. It's 14 raised to the exponent of 1/7. So the answer is not 2. So this will be a very small number because 14 to the first power is 14. And so I should expect something that's pretty small. And so we end up with 1.458 as an approximation. Because basically 1 to the 7th power is 1. 2 to the 7th power, which I mentioned earlier, is 128, I believe. So the answer here has to be between 1 and 2, because 1's not enough. 1/7 to 7. 2 is way too much. 2 to the 7th is 128. So 1.458 is the answer. So if I take that number, raise it to the 7th power, I should get an answer that's about 14. So 1.458 raised to the 7th is 14.005. Now, the reason why I'm a little bit over this time is because I rounded up to the 8. So that means the answer is a little bit too much. But again, very, very close to 14. So if you haven't tried number 11, I want you to go ahead and try it on your own and then turn the video back on when you're ready to continue. All right, so for the last one, again, we have 2/3 our exponent. I want to get a fraction that's going to equal 1. So if I multiply it by its reciprocal, I'll get 6/6, which is 1. So x to 2/3 equals 25. So I'm going to multiply the left side by 3/2 to get that 6/6, or x to the first. So we have 25 to the exponent of 3/2. So again, I'm not taking 25 times 3/2. Again, raise it to the exponent of 3/2. So your calculator will look something like this. You make sure you put the 3/2 as a division problem in parentheses. So this one here actually comes out to be a nice number. So 25 raised to the 3/2 exponent is going to be 125. Because basically the denominator of 2 means I'm looking for 2 identical factors that give me 25. That's 5 times 5. And the numerator says that I'm going to be multiplying 3 of those things together. So the number is 5, and I'm doing 3 of those. So 5 times 5 times 5 is 125. So some of these problems will work out to be really nice answers, but expect many of them to be decimal.